At this point in the chapter, we get to a type of problem called an optimization problem. And before I get to examples and steps and all that, I want you guys to know what optimization means. Optimization is basically just a fancy word for getting the best possible thing that you can. And it means different things. But what they all mean is they all basically mean finding the max or the minimum of something. So if you're trying to optimize cost, generally you don't want to find the maximum cost. Like, that doesn't make sense. You want to find the minimum cost for something. On the other hand, if you had a certain amount of money, if you only had like $100 to do a project, you would want to find the best thing you could get out of it. So optimization is really just sort of the real world version for finding the maximum or the minimum of something. And so in these problems, they're going to be word problems, and they're going to give you something. They're going to say, like, find the lowest cost of such and such, or find the greatest area of such and such. And what I hope you guys remember from the last several lessons is that when we want to find the max or the min, the way that we always do it is by taking the derivative of the thing that we want maximized or minimized and setting it equal to 0 or undefined. Like, that's a huge point in this chapter. If you want to find a max or min, you take the derivative, you set it equal to 0 or undefined. Because these are word problems with, like, real-world meaning, very rarely do we need to look at things being undefined. For these problems, I'm mostly looking at where the derivative is 0. I've got some steps for this, so we'll go into the steps in just a second, and then after that we'll get to examples. So the steps are coming up next. So here we go. I mean, I've listed it as 6 steps. I don't know that I don't actually think about these steps as I'm doing the problems, but it may be helpful for you to have them. So the first step, if necessary, it's not going to be necessary for this video, but in future videos, a lot of times you'll draw a diagram or a picture to help you label things, and the big part of that is labeling, so that you have a sense of what variables you're working with. The second step is that you have to identify the thing that you want to optimize, and write your optimization equation. And so this is where you really have to read the thing and you have to look and see, do they want the maximum product? Do they want the minimum cost? Do they want, the thing that has the least surface area? Whatever they want to be optimized, that's what your optimization equation is going to be. Right? And then third step, if that equation has 2 or more variables, which it pretty much always is going to, you're going to need to find some secondary equation, and you'll see that in the problems that we do coming up soon. Next, you're basically going to substitute that secondary equation into the optimization equation and get it ready to take the derivative. In the next step, you'll take the derivative and set it equal to 0. This is actually this is the step where the calculus actually happens. And then in step 6, this is really important. Answer the question. If it asked for the maximum product, then find the maximum product. If it asked you to find the minimum sum, then find the minimum sum. Make sure you answer the question that was asked. So I have two examples here, so let's get into those examples now. So here we go, my first example. I want us to find the maximum product of 2 numbers whose sum is 50. Alright, so step 1 is draw a diagram if necessary. This isn't really a diagram problem. We're not actually doing anything that has any geometric shapes or anything, so I'm not really going to worry about a diagram. The next step is to write what I call the optimization equation. And what that means is figure out what you need to optimize and write an equation for it. So in this problem, what is being optimized? What do they want to be either most or least? And I hope you find that the answer is the product. And in particular, it's the maximum product of 2 numbers. So I'm going to write P max, YP, because P stands for product, Y max, because I'm finding the maximum. P max equals, and what is the product of 2 numbers? Well, that would be X times Y. That's what I want to optimize. This is what I want to take the derivative of and set it equal to 0. That's what I'm going to do in step 5. Eventually, I'm going to take the derivative of this thing. But I can't really do that yet because there are multiple variables. There are sort of 2 variables here, and there's this, you could argue there are 3 variables here. So in order to get to the next step, I'm also going to need to come up with what I call a secondary equation. Right? And your secondary equation is somewhere else in the problem, right? It says here the maximum product of 2 numbers whose sum is 50. So how do we write the sum of 2 numbers? Well, this would be 50 equals x plus y. Notice that this equation is the one that says p max, and there's a max there. This one has nothing to do with a maximum or a minimum. This is just information. In fact, sometimes in the past I would have called this the information equation. Great. That was, I think, the third step. My fourth step is substitute. The idea is, hey, you want to take the derivative of this thing? Fine. Take the secondary equation and substitute it over here. So I'm going to solve over here for, I guess, x. It doesn't really matter. 50 minus y equals x, and let's plug that in over here. When I plug it in here, I get p max equals 50 minus y times y. In other words, p max is 50y minus y squared. And so the whole idea is I want to substitute this in over here so that I can take a derivative and set it equal to 0. Right? Is this now in a form where it's easy for me to take the derivative? The answer is yes, absolutely. I used to have two variables on this side, and now there's only one variable. I can do this derivative. So I'm going to get 50 minus 2y is equal to, and I guess I could write p prime over here like the derivative, but the whole point is that I'm taking the derivative so, whoops, I wanted the eraser there, wow. The whole point was I want to take this derivative so that I can set it equal to 0. Like, that's how we maximize things. That's how we find a maximum or minimum. It's either where the derivative is 0 or it's undefined. In either case, when I do this, I can move the 2y over, and 2y is 50. That means y is 25. Yay. At this point, your brain hopefully kind of goes into like autopilot. You've solved things enough to know, oh, I should plug that y back in. 50 minus 25 equals x. Great, that means x equals 25. Yay! At this point, you finish step 5. You're like, yay, I'm done with the problem. Step 6 is answer the freaking question. It said find the maximum product, which means you should find the maximum product. Right? In the beginning of this problem, we said that the maximum product was going to be x times y. So you should find out that that maximum product is 25 times 25. The answer to the question that was asked is 625. If you have two numbers that add up to 50, the largest possible product you will get is 625. And that's the question we just answered. I know I just took 4.5 minutes to do this problem. These problems usually go a lot faster than that. As you get the hang of them, as you get used to these steps, the process is going to go faster. I've got one more example for you that's mathematically a little bit more complex, but I think it'll be faster for us. So let's take a look at that one. So here we go. The product of two numbers is 60. Find the minimum value of the sum of 2 times the first number and 5 times the second number. So the first step is draw a picture if necessary. Again, no picture necessary. The next step is, what is your optimization equation? Okay. And I'd recommend pause the video for 10 seconds here. Write down what is it that needs to be optimized. What is it that I'm trying to make either largest or smallest? Okay. Well, hopefully you noticed it's supposed to be the minimum value, right? So you might say V for value, V min, minimum value. And what is the minimum value? Well, it's the sum of 2 times the first number and 5 times the second number. So mathematically, how do you write that? We should write that as 2x plus 5y. That's what I want to optimize. But because there are too many variables, I need to come up with a secondary equation. And again, pause the video for 10 seconds here. What is that secondary equation? We're told that the product of two numbers is 60. So 60 is x times y. Now some people want to put 2x or 2y here. I think the thing that I would point out is it says the sum of 2 times the first number, 5 times the second number. X was the first number, x was the first number, y was the second number. So those are the numbers that I use over here. In my next step, I'm supposed to take this secondary equation and plug it in over here. I can't do that till I solve for something, so I'll divide the y over. 60 over y equals x. When I plug that in, I get v min equals 2 times 60 over y plus 5y. And the idea now is, remember, my goal is to take the derivative and set it equal to 0. Please don't lose sight of that. The whole point of this entire thing is to take the derivative of that thing. And so what that means is, rewrite this thing. Move it into a form that's easy to take the derivative. So v min, I still haven't taken the derivative yet, equals 120y to the negative 1 plus 5y. I feel pretty comfortable taking the derivative now. I'm going to get 0 equals negative 120y to the negative 2 plus 5. And now I need to solve this thing for y, right? So I'm going to rewrite this thing as, like, move it to the bottom over y squared. And I'm also going to move that over to the other side. 120 over y squared equals 5. If that step didn't make sense, please make sure you take a second to see that. If I multiply the y squared over, I'll get 120 equals 5y squared. Divide the 5 and you'll get 24 equals y squared. You're basically going to get that y is the square root of 24. Right? I could rewrite that as 2 root 6, by the way. It's not necessary, but I'm going to do it anyway. When I plug that back in, I'll get 60 over 2 root 6 equals x. I'm going to multiply top and bottom by root 6 to rationalize. This is going to give me 60 root 6 over 2 times 6. Long story short, I'm going to get 5 root 6 equals x. So I got my x value, I got my y value. We're sort of done with step 5. The last step in this whole thing is supposed to be, what did the question ask for? This question asked for us to find the minimum value of the sum of 2 times the first number and 5 times the second number. They want this thing, right? So I'm going to bring that down to the bottom of the problem, right? They want minimum value of 2x plus 5y. So I'll plug those things in. 2 times 5 root 6 plus 5 times 2 root 6. That's going to give me 10 root 6 plus 10 root 6, and the answer to the question is 20 root 6, right? That's the minimum possible value that you can get of the sum of two numbers that do those things. That's the end of this video. The other videos that we're going to have tonight, I think, are just going to be other examples of different styles of problems. They should be shortish videos because we don't have all of the intro stuff. So I will see you there.